Hi, I'm Micah Woods, Chief Scientist at the Asian Turfgrass Center, and this is another ATC Doublecut. I'm going to take a look in this episode at the organic matter mineralization and the estimated nitrogen release from that. And I did a post on the blog about this where I compared Bangkok to Reykjavik. And I looked at the amount of organic matter mineralization that's expected to occur in those places. That post was called Soil Organic Matter and N Mineralization. And this is something that I have tried to figure out to explain it for a number of years. I've tried to predict it back in 2010 or so with some growth potential based calculations, and there's much better ways to do that. So I stopped doing it that way and started trying to calculate it more accurately. In a textbook, if we look in an agricultural textbook, we will find something that says you can expect in any 1 year from 1.5 to 4% of the total organic matter in the soil to mineralize. And the nitrogen in that organic matter will then become plant available. That's what mineralization means. And that works really good to express it on an annual basis when you're dealing with agricultural crops, because you're usually looking at an entire year equals one crop. But with turf grass, it's nice to break it down and look at it daily or weekly or monthly through the year, because we're growing grass all the time. So we want to know what's going on a daily basis. And in 2017 or so, I started using some calculations that were shared by Gilmore and Mauro Mostakos in an article that they called Nitrogen Mineralization from Soil Organic Matter, a Sequential Model. So I started using those, which allows me to calculate the mineralization based on expected soil water content, based on temperatures on a daily basis. And then I sum them for months. And doing it that way, it gives an annual total that still matches those textbook expectations for how much organic matter will be mineralized in an entire growing season. But now it can be expressed on a daily, weekly, or monthly basis, which is really useful for turf grass. Because what happens is if you have 5% organic matter in the soil or so, you will be getting during the summertime 1-2 grams of nitrogen per square meter per month mineralized, which is a quarter pound or a half pound of nitrogen mineralized per month per 1,000 square feet. That is plenty of nitrogen to support a pretty rapid turfgrass growth rate. And sometimes when we know that amount of nitrogen will be mineralized, it's not necessary to apply nitrogen fertilizer. So that's kind of the idea. And so why I did this blog post is because Iceland is very cold. And so you don't expect a lot of mineralization there. And yet I'd done some soil tests in October for a golf course in Iceland and found that the organic matter was a little bit higher than I'd expected. The organic matter at the 0 to 10 centimeter depth was above 3% on average, and that's relatively high. To put that into perspective, when we did the global soil survey and surveyed golf courses from all around the world, the putting green average in 100 putting green samples from multiple countries, multiple continents, the key condition being that the sample was from a putting green and it was identified as the person collecting the identified by the person collecting the sample as being good performing turf. What we found for the average there was 1.6, I believe. The average in the global soil survey was 1.6%. So when I was looking at samples in Iceland and saying, wow, that's 3%, the average is more than 3%, that's about double what is normal. And I wondered, in a place that's that cold, maybe the mineralization is just happening slower, and that allows the organic material to accumulate more. So I ran some calculations, and as a contrast to Reykjavik, I used Bangkok because Bangkok has high temperatures all through the year, so it's expected that the organic matter will mineralize at a much higher rate. And when I worked through these calculations, and you can see all the details in the post, I'll put the link to that in the description, and you can check this out if you're interested. But there's a factor of 5 difference. So in Bangkok, it's expected that for the same amount of starting organic matter in the soil, if we work through these mineralization calculations, which is, it's not exactly what happens, it's an estimate of what will happen, but there's a 5-fold difference in mineralization in Bangkok, 5 times more. So if we started, for example, with that average of 1.6% organic matter, which is normal for golf course putting greens, we would expect 5 times more of that organic matter would be mineralized, and 5 times more nitrogen would become available in a year in Bangkok than it would in Reykjavik. So what happens, I think, is the organic matter tends to break down more rapidly in a tropical climate, in a warmer place, and the organic matter in the soil breaks down more slowly in a colder climate, which I think is not it's not a very new discovery, because I think that's common knowledge. I was just interested to see how it worked with some turfgrass specific calculations, and with the organic matter calculations based on places that I've visited that I'm somewhat familiar with the turf in Bangkok and in Reykjavik. So that is something that I thought was interesting. I think that this is interesting also because if you think about what the implication of that is, it's that the organic matter is breaking down more rapidly in a hotter, warmer climate. And we often think in a tropical climate that the grass is growing so fast that it needs more organic matter management. It needs more sand top dressing, more verticutting, more core aeration, more material removed. But the organic matter is also breaking down in the soil more rapidly. So this is something that is a ongoing subject of topic of interest for me, and I'm going to try to I'm going to try to make the calculations a little bit more accurately, try to study a little bit more about what happens in temperate climates, in cold climates, and in tropical climates, so that I have a better understanding of this. But I think the subject of organic matter and carbon in turfgrass soils is going to be an interesting topic to people in the turfgrass industry and to people outside the turfgrass industry for many years to come. So it's something that I've been a little bit interested in, made a lot of notes about, but not too many calculations. And I did this blog post, found a 5-fold difference between Bangkok and Reykjavik, and I thought that was kind of interesting. So thanks for listening, and I'll see you next time on the ATC Doublecut.